after. Right, so here's what I want everyone to do. I want everyone to take down this question and draw the diagram as well, right? You're just taking down everything that I'm circling here. And then, of course, I will explain the question and, how to use differentiation to go about this, right? So take 2 minutes and we will get started on it. So you're going to pretend that you are a farmer, right? Let's just say you have a farm and you want to put up a fence to to prevent the cows from escaping. Now you're going to use nature to kind of help you out. Well, when you're putting up the fence against the river, the river itself is a natural fence. So when you're buying wire, you're only buying this part here. 1, 2, 3. There's no need to put any wire here. That's a kind of wavy line because we're going to assume that the cows are not suicidal and are not going to jump into the river, right? So how you say, the shape of the fence is supposed to be a rectangle. Now, how should we arrange the rectangle such that we use 600 meters of wire? So let me say we can only afford 600 meters of wire. Should we arrange it that over here is 500 and the two sides are 50? How much of you think that's the best way to arrange the fence so that we get the maximum area? Well, remember, 50 plus 50 plus the 500 is what? 600, right? We use all the wire. But isn't there an infinite amount of arrangements? For example, instead of using 50, 50, and 500, couldn't we use, let's say, 550 here and put 25 and 25 here? That would give us 600 meters of what? Wire. But we want to arrange the rectangle such that, not that we only use all the wire, but we get the maximum area possible. Okay? So what's going to happen here? We can actually use differentiation to help us figure out that puzzle. Remember when we talk about maximum or minimum? If you look back in the notes from a couple of weeks ago, whenever there is a maximum or minimum, dy dx is always equal to 0. In other words, when you differentiate once, you always put it equal to 0 if you are planning on finding what? Either maximum or minimum. But the problem is, whenever we differentiate once and we put it equal to 0, and we solve for whatever letter we're trying to solve for, we don't know if that letter gives us a maximum or a minimum, or all we know is it's either a maximum or minimum. To figure out whether it's a maximum or minimum, remember what we did 2 weeks ago? We had to differentiate a second time to get d squared y dx squared. And if you differentiate a second time and work it out, if you get a positive value, then that value we got was a minimum. If you instead get a negative, the value that we were testing actually gives you a maximum. Don't worry, I'm going to keep repeating it over and over and over. Also, you all realize that you all can only differentiate two variables. If you look back in all your notes, like y is equal to 3x, you can only differentiate if there are only two letters involved. So if the two variables, sorry, the keyword here is variables. If the two variables involved is y and x, when you differentiate one, you obviously get what? dy dx. If the two variables involved is a and let's say y, when you differentiate a and y, you'll get what? dA, dy. The point is, you as a Form 5 or a Form 4 student can only differentiate whenever there are two letters. when you reach Form 6, you will be able to differentiate like 3 letters and whatnot, but it's not on the CXC syllabus. So that means, let's just say I have this. If I come and give you 3 variables, A is equal to 6xy. Notice it have 3 letters here, A, X, and Y. Well, 3 variables. You all cannot differentiate that, that's way beyond the CXC level. So what do you do in a situation when there are 3 variables? Well, you're going to have to find a way to get rid of one of the variables so that you only end up with how much? 2. So let me just repeat that. If you are in a situation where you have 3 variables, you cannot work that out. You need to figure out a way to replace one of the variables. And don't worry, the examiner will always give you a kind of clue of how to replace one of the variables so that you end up with 2 variables. Okay? So let's handle the easiest possible question you can get in this type of questions. We want to find what? The maximum area. All right, so I'm going to use the letter A for area, which is a good idea. Anybody, and remember, when you open your exam paper, the examiner drew this diagram for you and it had the letter X and Y on it. How do you find the area of a rectangle again? Length by breadth. So anybody can send me on the chat the expression for area. If I'm trying to find the area, what 2 letters would I have to multiply to get the area? Right, Chantel, correct. Kiara, correct. Vishala, correct. Right. Right. You're multiplying X by Y, length by breadth, right? Just like a regular primary school question, except it's X and Y. So X by Y. It doesn't matter if you put the Y first or the X first, right? X by Y is obviously Y by X. So remember, what's the aim of the question? We want to find the maximum area. So when we hear the word maximum, all right, we know it has something to do with differentiation. But can I differentiate that expression in front of me? Is it possible for a Form 5 student to differentiate such a thing? The answer is no, because it has 3 variables, A, X, and Y. All right, so we have a little problem here. We have to either get rid of the X or we have to either get rid of the Y. It's not a good idea to get rid of A. You know why? Aren't we trying to find the greatest area? So the aim of the question is to find something dealing with area. So we need to keep A. A is the most important thing in that question, okay? So, like I said, the examiner will give you a kind of clue of how to replace one of the letters. And here's the clue. What's the length of the wire? 600 meters, right? So that means if we add X, Y, and X plus X is 2X plus Y. If we add up all of this, won't we get 600? So, tell me if this makes sense. 2X plus Y is equal to 600. Does that make sense? X plus X is 2X plus the Y is the... Are we all okay there? Right? We're good there, right? Take them up to there, take them up to there. 2X plus Y is equal to 600. So look at this. Did this come like almost a simultaneous equation, like a real broken simultaneous equation? Who is easier to make the subject there, X or Y? In the second equation I'm talking about, who is easier to make the subject, X or Y? The truth is, it doesn't matter who we make the subject, X or Y, but we're looking for the easy way out here. It's obviously easier to make Y the subject. We just take Mr. 2X and throw him across, and when you throw across 2X, positive 2X, you get what? Minus 2X. Look at that. Y is the subject. Y is on one side and everyone is on the other side. You see, if we made X the subject, we will have to throw across positive Y to get minus Y. and then divide everybody by 2. That seems to be more work to me, but even if you did it like that, you'll get the correct answer at the end of the question, right? Right. Now look at this. Keep your eyes on this guy here. And we could substitute it inside here. And we could throw away Mr. Y and replace him with how much? 600 minus 2x in brackets. So let's do that. A is equal to x. But I have to put it in brackets when you replace something, right? 600 minus 2x. And of course, I'm just going to expand the brackets now. You'll get 600x minus 2x squared. Everyone take down up to there. Put a little smiley face by this equation here. We call him Mr. Smiley, right? Right. Do you all see the good news now? At the beginning of the question, we had how much variables? A, X, and Y. You had 3 variables and you could not differentiate it. But look at Mr. Smiley now. How much variables it have? It only have 2 types. It only have A and X's, right? And you all can differentiate that. So now we can actually move forward with the question. There's nothing stopping us now from differentiating. So let's give you a little jump start. When you differentiate A and X, you're going to get dA, dx. Everyone by now should be able to differentiate this expression. Send the answer on the chat for me. Differentiate Mr. Smiley. When you differentiate this, you're going to get 600 minus 4x. Okay? If you didn't get it, resolve it, right? This was the differentiation we did on the first day of class. So we have just differentiated the Mr. Smiley. Now, whenever we're trying to find maximum or minimum, you see when you differentiate the first time, to find maximum or minimum, we always put it equal to what? 0. And of course, there's only one letter to solve for here. So could you all quickly solve for x? I'm letting you all know if you do it properly, you will get a positive value for x. Solve for x, right? Once again, whenever you're trying to find anything with maximum or minimum, once you differentiate once, you always put it equal to 0 and just automatically solve. What are we getting for x? Right. So we want to solve for x. So we throw across positive 600. You're going to get what? Minus 600. The minus 4 is a multiply. Throw it across. You get your divide. So x is what? 150. So when you solve for x, it's 150. The problem is we don't know whether this value of x will give us a maximum area or a minimum area. We know x is 150, but we need to make sure that it's a maximum and not a minimum. So what do you all have to do now? Remember this, like the first differential, 600 minus 4x. Differentiate one more time. What do you get when you differentiate this one more time? 600 minus 4x. When you differentiate that one more time, to get d squared a dx squared. Right? You can do that in your head, right? You're going to get minus 4. Isn't this a negative value? When it's negative, well, when the second differential is negative, we are dealing with a maximum. So that means this value of x here will give you a maximum area, right? So we need x to be how much? 150. So let's go back to my diagram here. So for us to get a maximum area, x has to be what? 150. You think you can calculate y? There are two ways to calculate y, but don't you have an equation here to calculate y? Once you know the value of x, you just substitute in x over here, 150, and minus it from 600. Or you could say the length of the fence is 600. You have 150 and 150. How much again you need to make what? 600, right? You do it any way you want. But that's technically a primary school question there, right? When you replace the x with 150 here, 2 by 150 is 300. 600 minus 300 is 300. So the farmer now knows how to arrange his fence. That particular arrangement will give you the maximum area. No other arrangement will give you a maximum area in terms of it being a rectangle. Now, like I said, this is the easiest possible question you can get in CXC with applying differentiation. That's that. Go. Right, so here's a slightly scarier looking situation. The farmer's farm has grown and now he only has 3 types of animals. Maybe it's cows, goats, and ducks. So he needs 3 sections, right? So this is how he plans to arrange his fence. Once again, he's using the river as a natural barrier. But this time, he only has money to buy 800 meters of wire. What should be the values of x and y, right? For him to get the maximum area for this scenario. So take down the question, draw it out and everything, and we'll work this one together. Let's see. Do we all agree that the area of one of the sections is just x by y, length by breadth, and the area of the middle section is another x by y, and the third section is obviously what? X by y? We could all agree with that? So xy plus xy plus another xy is how much xy? 3xy. So the area of this scenario is 3xy. Does everyone agree with that, at least? The first part there? That the area of the scenario is 3xy, right? It's just in length by breadth 3 times. All right, good. Erase this. Can we differentiate this scenario? The answer is no, because it has 3 types of letters, A, X, and Y. We need to get rid of one of the letters. And the examiner has given us a clue once again. What's the length of the wire? 800 meters. So how much X does it have? 1, 2, 3, 4. 4X, and how much Y does it have? 1, 2, 3. 4X plus 3Y is equal to how much? 800 meters. Right? Which one is easier to make the subject here? Now you gotta use your common sense here. Which one is the easier one to make the subject? Usually I would say X, right? But it takes a little bit of, how you say, experience to realize only this time Y is the easier one to make the subject. You know why? Because you'll end up dividing by 3. But then it have a 3 over here in the substitution. So the 2 3's would end up canceling out. So you won't end up with any fractions or decimals, right? So in other words, it's like this. We either have to make X or Y the subject. I'm telling you through experience, you're going to eventually realize, wait, no, it's easier, it's better in the long run to make Y the subject. Today, because when you throw across positive 4x, you'll get what? Minus 4x. and this 3 is a multiply, you're going to put one big divide by 3. So you're going to end up with y is equal to 800 minus 4x divided by 3. And then we're going to substitute it inside here. So let me show you how that will look. You have the area is equal to 3x, and in brackets, I put what? 800 minus 4x divided by 3. But look at this. The 3 and the 3 will cancel out, leaving you with what now? A real nice expression for the area. 800 by x is 800x, and minus 4x by x is minus 4x squared. This is Mr. Smiley now. Mr. Smiley is the equation where it only have 2 types of letters, 2 variables. So you can proceed with the question now. So I want everyone to take a try with this question now, right? See if you can finish off the question and get the dimensions for x and y. Anything to do with maximum or minimum, you just differentiate one. So even think too much about it. So you're going to get dA dx. We're going to get 800 minus 8x. Just put it equal to 0. And the only letter we could solve for here is x. Now, when you throw across positive 800, you'll get minus 800. And then we're going to end up dividing by minus 8. So when we solve for x, we're going to get positive 100. Right? So I think a lot of people send that answer. So all the x's in the diagram would be what? 100 meters. We just need to find, oh, sorry. We need to confirm it's what? A maximum, right? So that was, I forgot about that. So let's differentiate one more time. When we differentiate this expression one more time, we're going to end up with minus 8, indicating that it's a maximum, a straight out maximum. So yes, now it's okay for me to say all the x's need to be 100 for a maximum. To get the corresponding y value, just look through your working and look for any equation where y is the subject. Look it over here, have a little arrow there. So if y is the subject, just replace x with how much? 100. So replace this x with 100. 4 by 100 is 400. 800 minus 400 is how much? 400. 400 divided by 3 is 133. I know some of you will put 0.33, but 133 and 1/3 or 133.33 is also correct. So those are the dimensions we need. We need x to be 100 and y to be 133 and 1/3. This is the second hardest possible question you can get, right? And of course, it can come in the exam. Not because I'm saying it's not that hard, mean it cannot come, right? You can get lucky that you're in the exam and get something this easy. Slightly harder question. This one involves an open container. In case you don't know what an open container is, it does not have a lid. Right, so you can push your hand into it, right? So an open tank is a tank without a lid. That is all it is, really. Right, so take down the question, draw the diagram, and we're going to work it out together. Right? Remember, it's an open container, and we're looking for an expression for the surface area, the area of the material. Remember, if here's H, then over here is also H, and here's also H, and behind there's also H, right? Right. You realize the base is a square, right? Because it's what? X by X. So the base is X squared. But every other rectangle is just what? H by X, length by breadth. But it have 4 of them. So it's 4XH or 4HX. Anyhow you want to write it. For those who are struggling to find the expression for the surface area, you think you understand it now? Because remember, it doesn't have a top, it doesn't have a cover, it's an open container. Great. Now we have a little problem here, right? We have how much letters here, right? We have 3 letters, A, X, and H. We can't work with 3 letters. So we have to work with what? Getting rid of one of the letters. Now, look at it. Didn't the examiner tell you that the tank can hold 8 meters cube of water? Isn't that volume? I mean, the examiner could have been straightforward and said, the volume of the container is 8. But he said it in a sneaky way. How do you find volume? Length by breadth by height. So that means length by breadth by height is equal to 8. X by x is x squared, that is length by breadth by height. So look at that. We have an expression that allows us to get rid of one of the letters. Now it's obviously going to be easier to get what? Make h the subject here. Throw across the x squared, which is a secret multiply. Throw it across, you get what? A divide. Look at this now, guys. Look at this. And you can replace it inside here. Throw away Mr. H with what? 8 over x squared. Simplify, and you will get Mr. Smiley. The equation with only 2 types of letters. Take it from there. Substitute H into the first equation. Simplify, and everything should be straightforward from that point. Good luck. A replacing H, right? So it's A is equal to x squared plus 4x. I'll use a different color. Throw away Mr. H and replace him with 8 over x squared. This x will cancel out with this squared. Anybody getting something like this? X squared plus 4 by 8 is 32. And I have a little x underneath here. Looking good there? This seems to be what? Mr. Smiley. Now, remember I told you all it's not a good idea. I mean, we know we have to start the differentiation now, right? Because we only have 2 types of letters, A and X. But I remember saying over and over, don't try to differentiate when X is underneath. Remember, this is really X to the power 1, right? Throw him on top and make him what? X to the power minus 1. It's going to make your life easier when it comes to differentiating it. Okay? So take it from there, guys. Differentiate once, put it equal to 0, and see if we could solve for X. Right, this one will be a little bit harder. No problem. That's it. Do this in slow motion, right? Differentiate once, dA dx. When you differentiate x squared, you'll get 2x. That's easy. This one, you throw the power in front, so the minus 1 will meet the 32. So you get minus 32. And then you minus 1 from the power. Minus 1 is minus 2. How much people at least had that after they differentiated that, right? Real people, all right, good. Real people telling me they're getting that. Now, we're going to put it equal to what? 0. Now, the thing about it, this minus 2, let me throw it underneath for the calculations, right? So I'll throw this underneath, and it becomes what? Positive 2. So we get a nice little x squared there. So I remember doing this question in Form 5. Just to tell you how old this particular question is, right? But the question hasn't changed over how much ever years that was. So I too was stuck on this. Like, how am I going to solve this, right? Nobody never showed me how to solve this. But then my teacher, right? You know what he did? Remember, this is minus 32 over x squared. And if I throw this over, I will get 2x is equal to positive 32 over x squared, because this whole expression is negative, and I throw it across, right? And you all could do what now? cross multiply and solve for x. Cross multiply and solve for x. Remember, when you throw across a squared and you just get a square root, when you throw across a cube, you get what? Cube root. The opposite of squared is square root, and the opposite of cube is cube root. I hope that helps. You get a decimal for this one. Well, when you cross multiply, 2x by x squared is 2x what? Cube, right? 2x by x squared is 2x cubed. 32 by 1 is 32. We're trying to solve for x. 2 is a multiply, throw it across, you get what? A divide. So x cubed, how much is 32? That's how we make sure. 32 divided by 2 is what? 32 divided by 2 is 16. When you throw across a cube, you're going to get a cube root. Find the cube root button on your calculator, right? Right? The cube root button looks like this on the calculator. It looks like a square root, but it has a small tree. When you throw across cube, once again, you get cube root. I'm getting to 2 decimal places, 2.52. Right? Now, different calculators have the cube root button in different positions, so you're going to have to look. So look at it. I'm repeating it. So we don't know whether this x gives us a maximum or minimum, but because the question said least, we need to ensure it is a minimum. So we need to differentiate one more time. Let's clear up the clutter here. Remember, the value we're testing is what? 2.52. Now, it had a squared here, right? It's time to differentiate one more time. So throw that x squared on top, right? So I'm throwing them back on top because it's time to differentiate. Differentiate one more time and let me know what you guys got. Anybody got this? You got 2 plus, no, remember, it's plus, eh? When you throw the minus 2 in front, remember you have a minus 32 here. So minus 2 by minus 32 is positive 64. And then you minus 1 from the power. Minus 2 minus 1 is minus 3. But I don't like how that minus 3 looks, so I'm going to throw it underneath, and it becomes what? Positive. Look for your mistakes. Some people thought it was a negative 64. Now this, when we differentiated it a second time, you all notice we can't figure out whether this is positive or negative as yet. In the other questions, as soon as we differentiated a second time, it was 100% clear whether it was positive or negative. But we end up with an expression for the second differential. So we have to replace x now with the value we are test running. So we're going to enter the 2.52, work this entire thing out, and then ask ourselves now, are we getting a positive value or a negative value? So replace the x with 2.52, work it out, and let me know if it ended up with a positive value or a negative value. It should be obvious what kind of value you're going to get, but do it just in case. 64 divided by 2.52 cube, and then we add 2. Anybody getting something real close to 6, like again 5.9999, approximately positive 6? Anybody can confirm that? And of course, 6 is what kind of value? A positive value. Positive is minimum, right? Positive is minimum. So this value of x, this 2.52, well, he is great for minimum values, and we want a minimum value. Now that we have the value of what? Now that we have what? X, and we can calculate the H value. Now, how do you calculate the H value? Replace the X with what? 2.52. So take 8 and divide it by 2.52 and get the H value. So I'm putting the X value here, 2.52, and the H value is how much? Navid is sure I'm getting something different, but I'm going to double check it again just now. But I'm getting something different for each. Right, so anybody getting 1.75 for each? 1.75? Let me double check that part. 8 divided by 2.52 squared. Oh, no, sorry. It seems that I made a mistake. It's 2.26. Sorry, my mistake there, guys. 2.26. Yeah, that's the correct answer. Navid, you got that too? 2.26? I mean 1.26? All right, great. Now, usually this would be the end of the question. So to get the least amount of material, the X value needs to be how much? 2.52, and the H value needs to be 1.26, right? Usually that would be the end of the question. But if you read the question properly, they ask you what's the least amount of material. So they want a final answer for the surface area. What's the least amount of surface area? That means you have to go to the first equation now and replace the X with what? 2.52. Any X you see with 2.52, and any H's with what? 1.26. In other words, replace the X and H's with the minimum values and work out the minimum surface area, right? So this question went one step further, where they just didn't want only the values of X and H to give you the minimum surface area. Now they want you to actually calculate the minimum surface area. So you think you all can finish out the question there now? Replace all in the first equation, the black equation, every X you see with 2.52 and any H you see with 1.26, right? And a lot of students would have missed that, right? So running out of space are going up here. Right? So when I work it out, I'm getting 19.05, right? I would ask you for the surface area, it would be in meters, so it's meters squared, right? So, and that's the end of the question then, 19.05 meter squared. Oh Lord, this one looks like trouble. All right. Yeah, I needed it right. Hey, what? No, but just screenshot it. If you write this down, we're not gonna finish it. Okay. So just screenshot it, and you all just get started on the question. I know it looks intimidating, but it's the same concept. You're gonna try to get what? You're gonna start off with 3 letters, and you're gonna have to try to get what? Rid of one of the letters. Right? Right. So, but isn't this a closed cylinder? So it has a lid underneath and a lid on top. So after we fold it, we can cork it on top and cork it underneath. Does it make sense? And how do you find the area, or how do you find the area of a circle? Isn't it pi r squared? And this circle on top is what? Pi r squared. By the way, this is the pi r squared on top, the lid underneath, the lid on top, and this is the lid underneath. So what's the total surface area of a cylinder? It's the area of the rectangular part plus the two circles, the pink circle on top and the pink circle underneath. So the surface area of a cylinder is length by breadth, 2 pi r each, length by breadth, plus how much circles? Two circles, so it's 2 pi r squared. That's the surface area of a cylinder, right? I know this is a lot to take in. I have a good feeling I'm going to have to start with this question tomorrow when everybody has a fresh. How do you find the volume, right? They ask you to prove that the volume is this expression. How do you find the volume of a cylinder again? The volume of a cylinder is pi r squared by height. That's a standard what? Formula. Volume is what? Pi r squared by height. But you all notice their expression only has the letter R in it. Our expression for volume has V, R, and H in it, right? What do we need to do? Remember, they told us the surface area is 30,000. So we can replace the A with 30,000. And we can make H the subject now. We can get H on one side and everyone else on the other side. And when we make H the subject, we could substitute the H over here. And when we substitute the H over here and simplify it, I bet we will get the expression on top. Not too sure if you can wrap your head around that one, right? Well, give me some feedback if for those who want to try it. Remember, they told us that the surface area is 30,000. They told us, right? So all I am saying is that if you unwrap this cylinder, you will get a rectangle. And you will get a circle underneath, that is this circle underneath, and a circle on top, the cover and the bottom, right? Over here is obviously H. I think that's the easiest part to understand. Remember, the distance around a circle is the circumference. Circumference is 2 pi r according to regular boring maths. So that means from here to here is the circumference. We just unwrapping the circumference. So it's 2 pi r. So the area of the rectangle is length by breadth. So we're trying to find the total area of that shape. The rectangular part is length by breadth, 2 pi r by h. Plus, we have to add the area of the circle on top and the area of the circle underneath. The area of the circle on top is pi r squared. The area of the circle underneath is what? Pi r squared. So how much pi r squared do we have? 2 pi r squared. So that is the expression for the area. And the examiner told us the area was how much? 30,000. For those who didn't catch it the first time, you think you catch it now? All right.